scalability, fault tolerance, high volume, reliability, data transformation, extensity, replication, zero downtime performance. Now, Apache Kafka can handle scalability in all 4 dimensions. That is very important. That's why it's so much famous. It has event producers, event processors, event consumers, event connectors. So this is what which makes it, scale in all 4 dimensions. Kafka can handle high volume, right? We know that in Netflix, to date, it is handling 700 billion messages per day. I'm repeating the figure. 700 billion messages per day. Kafka offers provision for deriving new data streams using data streams and producers. It has false tolerance because of its Kafka cluster. It's reliable because it is distributed, partition, replicated, and fault tolerant. It is durable because Kafka is a distributed commit log. That means messages persist on disk as fast as possible. For both publishing and subscribing messages, Kafka has high throughput. This is one of the #1 factor where everybody jumps for Kafka. Even if many TB of messages is stored, it maintains stable performance. Terabytes, I'm not talking about gigabytes, terabytes. It has zero downtime because Kafka is very fast and guarantees zero downtime and zero data loss. It is extensible. There are many ways which applications can make use of Kafka. And in addition, offer ways by which you can write new connectors as needed. Ingest pipelines is the one which is an important feature by which
add all these dependencies for Kafka, and then we generate a message. We need Kafka messaging, Spring Web, Spring Cloud messaging, Spring Apache for Kafka streams. Then after that you generate the zip, and then I imported this in the class. And what you see now is imported code. And I have the Spring Boot application here, which is basically, runs the class. And here I'm trying a drug example. That means we have a business object drug. It has an ID. It has a name. And it is persisted because it's an entity. So what I'm going to do is that I'm going to publish this message as an entity. Next thing is we have a drug publisher. Now this special thing you need to note that is that I'm using one more feature, that is enable binding. That means I'm binding a Kafka. But when I write publisher, please note that there is no code specific to Kafka here, right? I'm using a message channel. And this is my REST API, right? It is routed to, it's configured to route. That means if you enter publish drug API, it's going to publish the messages. So this is a publish event, and I'm going to publish what? REST API, right? It is routed to, it's configured to route. That means if you enter publish drug API, it's going to publish the messages. So this is a publish event, and I'm going to publish what? I'm going to publish the business class object drug. So note that the message channel which is there here in this case, it has a lot of methods to work on, but we are going to use send message, where it's going to send a generic message, and in the message we are going to combine our object. So we are using a message builder and our payload with a payload we queue our business object. So we have a drug subscriber, and this is where your stream listener comes into picture. We are going to consume the message. The message consists of details of the drug object. So far so good. Now what we are going to do, we're going to start the Kafka, the Zookeeper. And then when we start the Kafka, the Zookeeper, why are we mentioning about Zookeeper here? So you need to remember one thing that, you know, in Kafka messaging system, we have brokers. As you know, a broker is a medium between the is the one which helps us to publish and subscribe messages, right? Publish and subscriber never talk directly to each other, which or if you don't know, you can see one of my previous videos where I talk about what is the role of a broker. Now you have several brokers and there is some replication going on. The Kafka as a cluster also has leaders. I'm not going to go more deep into that because this episode is not focused on that. And the Zookeeper simply interacts with the overall system. It makes sure it participates in the leader election. It makes sure that the replication system is going fine. So let's see what Zookeeper does in Kafka, just for our understanding's sake. Zookeeper. So Zookeeper is basically a top-level software developed by Apache, and it's access a centralized service. It's used to maintain naming and configuration data. So the data within Zookeeper is divided across multiple collection of nodes. Basically, to show a pictorial diagram, I would show you how it looks. So this is the way, the data with Zookeeper is divided across multiple collection of nodes. And this is how it achieves high availability and consistency. So in case node fails, Zookeepers can perform instant failover migration. Then next question is why Zookeeper is necessary for Apache Kafka. So it helps in controller election. That means there is always a leader in the cluster of Apache Kafka. It helps for that. The control is one of the most important broking entity in Kafka ecosystem, right? And it also has a response to maintain the leader-follower relationship across all the partitions. If a node by some reason is shutting down, its controller is responsible to tell all the replicas to act as partition leaders in order to fulfill the duties of these partition leaders on the node that is about to fail. So whenever a node shuts down, a new controller can be elected and it can make sure that at any given time, there is only one controller and all the follower nodes have agreed on that. Similar to our kind old story when the king dies, his son becomes the king, right? Similar system. Configuration of topics, the configuration regarding all the topics, including a list of existing topics, the number of partitions for each topic, location of all the replicas, list of configuration overrides for all topics, and which node is produced preferred leader, those things. And you have access control list, then you have membership of the cluster. Zookeeper maintains a list of all that brokers, that are functioning at any given moment. And then one thing you need to remember that you can't run Kafka services without first installing Zookeeper. So Zookeeper is mandatory. So you can connect to Zookeeper. So there is a CLI using local IP addresses. You need to connect from a virtual private connection that is paired with cloud Kafka VPC. You can connect using ZTI client, right? Server private IP. So this is a short introduction of Zookeeper. I'm not going to go more deep into this. Next, let's think on how do we start the Zookeeper and Kafka. So let's start the Zookeeper now. Actually, the Zookeeper.properties is in configuration, but I copied it here. So let's start the Zookeeper. Now we are starting a single node Kafka cluster. Then, okay, we started the Zookeeper. Let's start the Kafka cluster. So now let's start the Kafka server. Okay, we started the Kafka server. Now we need to understand the Kafka messaging system. Sometimes people, ask these questions. Why Kafka? There are so many middlewares, right? We have TIBCO, we have RabbitMQ, we have IBMQ, we have Tuxedo. So many middlewares are there. Why Kafka, right? So there is a very basic difference between the standard messaging systems and the Kafka messaging system. So we need to understand that at this point. What exactly are those differences between the standard messaging system and the Kafka? So unless I introduce those concepts, I will not be completely showing the value out of Kafka to you.